All right, welcome back. We are WEBD6201 in the winter 2020 semester, and it's at Durham, and it's week 9, part 2 of our broadcast. We're talking about an intro to NodeJS, but before we get there, let's do some administrative stuff and talk about Lab 3, which is fun with Ajax. Like I said, fun with Ajax, fun. All right, let's talk about what this thing is and what you need to do to be successful for Lab 3. So again, it's with 5%, so smaller lab, made to practice Ajax API. That's what it is. There is a GitHub link that I'd like you to use, Lab 3, which is basically, if you download it, let's just go there now and take a look at it. So Lab 3 is up here on GitHub. Okay, so you can grab that link to start Lab 3, and let's go there and take a look at it. Now this is not a complete one for me, right? This is one for you guys to do, and you need to do this so that you can do test 3 successfully. So one kind of thing is going to be built on the other one. We'll talk about this one in a second. So this is what Lab 3 looks like. This is like the Ajax stuff that we were doing before. And if I was to run this like normal, then what you're going to get with Lab 3 is pretty much the stuff from last week. Okay. Notice that products is now working, so it's loading a file from the JSON file there for you. Services, about us, and contact us. That's all kind of working as much as possible. The one thing that's not working, if you notice, is the link. Don't worry about that right now. That's another step that we'd have to take, and I didn't really talk about how to fix that problem. But more or less, the website is all working now. So that's the one you're going to be basing your Lab 3 from. However, there is this thing that you did on Test 2, the task list that you made on Test 2. Remember this task list? Well, the task list, what it is just a traditional website, right? So your task, your job for Lab 3 is to take this task list and make it into a content area. We're in a single page application structure that we've been making. We're using index.html as a template, and I want you to take tasklist.html and make it functional. All right, so that means that take it and put it inside the views content folder, call it tasklist.html, but strip out everything but the content area, just like we've done before in the past. So that's your job, really. Take it, strip it out. And once you've done this, in the app.js file, so let's take a look at our structure here for a second. Under our scripts, we have app.js. I've included the solution for test 2 way at the bottom. And this is your function. It's called display task list. So the display task list function is here, but it's non-functional. Why? Because task list is still just a regular HTML page. What we want to do is make this display task list function work while we've used Ajax to load up our page as a content area that we're going to inject into our template. Okay, so what do I mean by that? Well, if you look, I'm already doing that, right? Like if you notice way up here in this large file that we have going on, we have this stuff almost like a switcher based on our address, right? So when someone clicks on the home link, then they go to the load page content, they load inside the main content area, and they load some stuff, right? And then here's the products. So the way products works is you go to your load page content, use this file, you target the element that you're injecting into, you've got the page that you're injecting, and then look, here is the JavaScript part. This is the callback that you're pointing to, and I know Spencer, you were asking maybe last week. Remember callbacks? Yep. Sorry to interrupt you. No. But that's how it is. That's how you would do it. So I'm giving you you've already got the formula for how to do it. Your lab is really, really small. All I'm asking you to do is make that task list work. Now, there's going to be some different things here. Why? Because if you notice in normally what we would do is we would look at the, here's our index.html template. Remember, template has a header, it has a container and a main footer. And just to make everything work easier, I've just removed the scripts section in here and just made it so that it's part of the template for now. Because there's a way of doing it, but the problem is that jQuery also has to load at the right time. Because if it's not loaded at the right time, if it's loaded after the other ones, it's actually supposed to load before the other stuff. And there's ways of doing that. I don't want to overcomplicate things, so I've just included it in our template for now. Okay? But basically what you have is a main header, a container, and a main footer, and or a main content. And these three areas are where we're injecting content right now to make our single page application, or our spot. That's what it's called, right? So, so far we've been injecting stuff, but we use the main header for that, because when I go to views, and if I look at my, if I go to partials and if I go to header, you can see that this header is our nav bar, right? So this is our nav bar. It has all the links, right? But what I'm asking you to do now is, when you go to the content area that is home.html, there's another button. The other button is task list button, right? When you click on this task list button, you're going to load content, and you're going to replace this content with the task list content. Okay, that's what's going to happen, right? Because the content that's in here right now is the content for the home.html. But when you click on this button, what's going to really happen is you're going to just replace this content with the new stuff. Okay, so that's where it's a little different. You're not actually going to use the nav link to do it, and that's where this code comes in. This is using the active navbar function in order for you to do this. So you're going to have to do something very similar to this to make your task list.html work. Okay, it's very similar to that. That is your job to make that work. And if you look at if we take a look at the document, again, this is the new structure. Notice that the new file, tasklist.html, is there. You have scripts. You also have a views folder. In your views folders where you're going to do some work. I've also included a favicon.icon, just because I can't stand that error, the 404 that comes up that says your favicon doesn't exist, right? So I've kind of put one in there just to have something. It's not really special at all. It's just like literally a couple of pixels that are in there. And then what you want to do is you want to make this task list work. So that's what the task list looks like. And I'm not asking you to do anything else other than what is already there. There's no code for you to do to make this task list work. It already works. You've already done that code for your test number 2. All I'm asking you to do is get the functionality working inside the single page application structure. That's all I want you guys to do, right? That's lab 3. Okay. Test 3 is going to be based on you finishing lab 3. However, if you don't get it done, I'm going to give you a solution for it that you can base your test 3 on. That's why I can't give you test 3 right now, because it has to have a completed version, a template that I got to give you that is the solution for this thing, right? So next week, when you hand this in, this thing will be due on Monday, March the 16th. That's next Monday. That's when it'll be due at midnight. You have some time to do that over the weekend or whatever, get it done, right? And then on Tuesday, when we get together, I'll give you the solution for lab 3, and I'll use the solution for lab 3 as the template for test 3, which will be due at the end of the week, next week. Okay, which will be the Friday, whatever that Friday is. Okay, there you go. Okay, so that's the plan for this thing. And you can see that there's only a few little things you have to do. One is you're going to convert the task list.html page to a content page. And like it says here, there is no JavaScript required for this step. There isn't. Converting a page to one thing is like literally copy pasting, right? You get 2 marks for that. Task list page, these 2 are the only things you have to do. One is inject the task list content into the main element of the index page when the user clicks the task list button. This is the one thing that I was telling you. It's a slightly different thing than using the nav bar. Okay, that's one thing. And the other part is make it functional. Make it functional. Make that display task list function work right inside of your new structure. If you can do those 2 things, I think you'll understand what you need to do for your test number 3. So it's very straightforward. This one is definitely an easier one than the other ones that I've done, and I want to kind of vary that the intensity, some easy ones, some a little bit harder, and then add some more stuff. On that, administratively, we are on lab 3 test. We're on the right test around. We have like 4 tests. So we got 3 tests going to happen by next week. So we're pretty good there. But labs are a little bit behind. So you're just keep in mind we're sitting at week 9 right now. Next week is week 10. I guarantee you that in order for me to keep up, because I have week 10, 11, 12, 13, and 14, right? Those are the 4 weeks I have left, right? 4 weeks. I've given you 3 labs, and I'm supposed to give you 8. That means either I give you a lab every single week, that's due. It means like something to do every single week. And not that difficult for me to do. I can make it small. Or I compress maybe 1 lab or 2 labs together and make it like 10% or something. It'll be like, it'll say like on the document, lab 1 and lab 2. Or in this case, it'll be lab 5 and lab 6 or something like that. It'll be both those 2 labs together combined. And there'll be 2 parts to it. So you actually get them together, right? So you have lab 5, 1 part, and lab 6, something else. That'll mark literally separately, but it'll be 1 document and you'll get it at the same time. That's what I'm going to do, chances are. Because in order for me to catch up with the class, I can't do it any other way. There's supposed to be 8 evaluations in this course. I think it's a lot, but it is what it is. And so I'm going to hand them out to you, but you might get them all together in one. Okay? So just let me know. Which means that by the end, you'll be getting like, kind of a meteor labs coming up. They'll be worth a couple labs worth. You might get one that's worth 5 and 7.5%. One that's worth 5, part 1. Part 2 is worth 7.5%. That'll be, let's say, for example, lab 5 and lab 6, let's just say. And then it'll be worth 12.5%, right? So it'll be a little bit more than a test. However, there'll be 2 parts to it. So I'll definitely rank it separately. So you're not going to, if you do one and you don't get to do the other, or if you don't understand how to do the second part, it's okay. Okay, questions around anything administratively that we've talked about today. So lab 3 is released, and then we'll get moving with all that other stuff upcoming next week. All right, so for the second part that I want to talk about today, it's all around NodeJS. I want to do a little bit more theory today, some concepts that we kind of missed out on doing last week or last day because I did a kind of a practical example. I will still continue with the practical example today. However, because we moved into using Express, and next week is about Express, right? We're just a little bit ahead in terms of what we're doing, right? And this is good, because remember, what you're going to be expected to do by the end is full CRUD with Express. That means create, read, update, delete, and Mongo. That means over the next 2 weeks, I've got to teach you Express fully, access to Mongo, and put it up live somehow, right, on Heroku. So it's going to be pretty challenging. Typically, when I do this with other classes, when I talk about Node.js, which is really, the kind of the meat and bones of this next section, it usually takes me a little bit longer to do everything. Okay, only because there's just a lot of stuff to do. Okay, but however, I'm going to try and compress it so that we can fit everything in until the end. Okay. All right, so last week we talked about Ajax, and we also had Lab 2 and Test 2. You guys did those. I got to mark those. This week we're going to be talking about kind of the evolution of JavaScript a little bit. We've talked about it a little bit because we've moved from ECMAScript 5 to ECMAScript 6, but there's even more of an evolution happening with Node.js. And we've talked about it. I've already talked about Node.js, but I want to focus in a little bit more on that today. Okay. Also, Lab 3 is released, and Lab Test 3 will be released by the end of the week. The details of it will come out, but I can't give you the template until next week. So you'll have to wait till the template happens early next week, Tuesday. All right, so let's talk about the evolution of JavaScript a little bit. So really, at the end of the day, when we talk about stuff, I always think about web development in 3 phases, really, at the end of the day. We have our structure, which is our HTML, right? We have our presentation, which is our CSS, right? And then we have our behavior, which is your JavaScript. Those are the 3 phases, if you will, of regular web development. So this is beyond, I'm talking about like client-side stuff. This is beyond anything else that we've we've talked about so far. So that's kind of like the structure we've been going with. These are the layers that we're talking about. So again, I kind of talked about this at the beginning. You can't have any JavaScript, or JavaScript doesn't make any sense without content, right? JavaScript doesn't make any sense without some kind of presentation, CSS. That's why we've been using Bootstrap this entire time, right? We want to use JavaScript in order for us to add behavior, okay? But now we're talking about not just client-side stuff, but we're talking about server-side stuff. And so what's happened is most modern web applications get built on this idea of a model view controller framework, okay? Model view controller. And I kind of talked about it really briefly yesterday. So think about the model as a class that connects us to our data, right? We have some kind of data that's sitting on the cloud somewhere. It could be serverless. It could be with SQL, a SQL server. It could be a NoSQL server. It could be somewhere, right? But we need to be able to connect to it, and we need some schema, some way of structuring our data. So when it comes in, we deserialize it, right? We deserialize it and use it in our code. And what I mean by deserializing it is when we put things up in a database, we serialize our data. We encode it so that it fits in columns and rows. That's what we do, right? And so what we need to do is take the data, deserialize it, and inject it into our page somehow in some kind of human readable structure using HTML, right, or something like that, so we can see the data again. And in order for us to do that, we need a model for that to happen. And the model is our data class, our class that connects us to the database, okay? Then we have a way of displaying our pages. We're going to do this round trip, right, just like we've done with Ajax. We're going to go out to the server, make a request. The server's going to take that request, process it, and respond with something. And it's going to respond with some kind of HTML. And the way it's going to do it was with, by kind of displaying a view, the appropriate view based on your request. So example, if I go to my index.html page, I'm going to request from the server to get the index.html content back. That's what's happening. So I make a request. Usually this type of request, when I want to view a page, is called a GET request. I make a GET request, and it makes a full trip, and it comes back with a response, and I see my index.html, my HTML content. That's what I see. So that is the presentation layer. And what we're going to be doing right now is splitting stuff, just like we did with Ajax, into views. We're going to split it down into views, okay? And then finally, we have our logic, all right, or our controller. And the controller on the back end, what it does is it controls routing more than anything else, and any kind of intelligence that happens on the back end. We're not talking about client-side logic anymore. We're talking about server-side logic. For example, I want to go, again, to a page. One thing is I want to display the view, but how does the view get displayed? Through the controller. How do I get data? Through the controller. So the model view controller structure or design pattern, if you will, it's all interconnected, and we're going to talk about it. So again, this is a standard application structure. We have some kind of database, we have some kind of client, and we have some kind of server, right? And usually this can take in different forms. So again, the server could be a PHP server. The server could be you could use Apache and PHP. You could have the server could be something like a IIS server, Internet Information Services equivalent now, or Microsoft Azure in the cloud, Amazon Web Services, something on the back end that basically serves up is the infrastructure for your data. That's what it is. And then the client could be most likely is your browser. And there's some kind of data store, database, whether it's server or serverless. Okay? So this whole MVC structure is what we're talking about, and it looks like this. It kind of looks like, you got your model, your user makes a request to the server, right? The server, the request passes through the controller, which is just a class. That's what it is. And the class processes the user's request, and if it needs to, it can fetch data through the model class. So the model connects to the database, let's just say, and then it returns data into the view, and the view returns back to the user. That's how it normally goes, okay? Now, again, this is just our structure. That's how it looks like. So again, back in the day, we had this idea of a solution stack. And we talked about this before. The AMP stack, which is Apache, MySQL, and PHP, and the .NET stack are two very, very popular frameworks, and they were able to provide this rich content. Dynamic HTML is what used to be called, DHTML. And they did it through a combination of connecting to the back end of the server and the server responding with from requests from the user. So again, remember that JavaScript is a interpreted language. These are the things we talked about before. And one back in the day, and you probably have heard this before, but there was this thing called Netscape Navigator, right? And actually, I'll be honest with you, I loved Netscape. It was very simple. It was very straightforward. It had its flaws, obviously, and it's basically how all modern web browsers evolved, right? We have Netscape, and then here we are, right, with Chrome, mostly in Firefox and Safari. I'm not going to mention Edge too much. So again, we started to develop these new tools. jQuery was born, right? Because jQuery, we needed something to help us with some of the CSS, because back in the day, literally there were just links on the page. There wasn't any images, or anything like that. And so jQuery helped us out. But we kept on evolving and evolving, and I'm kind of fast forwarding here because you don't want to care. I'm sure none of us really care too much about history. So let's just move forward a little bit. So in 2008, Google came out with this idea of a V8 engine. Okay, so the V8 engine it's kind of a just-in-time, fast compiling engine, and it allows us to compile more complex code. Actually, our browser sped up in 2008. Before 2008, we had older browsers like IE3, if I'm not wrong, or IE6. Sorry, I'm aging myself a little bit. But basically, that's what it was. It was like, IE6. It wasn't very good. And then once this new V8 engine came out with Chrome, it enabled more technology to kind of come into play. And one of this kind of an offshoot from the V8 engine was NodeJS. Okay, that's where it came from. So one of the things that happened, this dude, Ryan Dahl, right? He was the guy that created Node. And there was a schism, right? Believe it or not. There was back in the day, there was these two organizations, the community organization and this other organization that kind of took over Node.js. And Node.js.org for a long time had a different version than his version. He ran Node.io, and Node.js.org, they kind of were doing something totally different. And for a long time, our Node.js version was at like something like 0.8. No joke, right? 0.8. And then all of a sudden, these two groups came together, and suddenly it jumped to like version 4. That's what ended up happening. This is, by the way, this is like around 2012 time frame, right? Or 2010. So it wasn't that long ago. 2012, I think it was 2012. So, so really what this is, this idea was that Node.js would be using this non-blocking, kind of a responsive back-end framework that did not use, a multi-threaded environment at all, right? Didn't use multi-threaded environment. What it did instead was it used an event queue. So it was created, and it was really, really fast. People really liked it. And then this other guy, actually these two dudes, Dwight Merriman and Elliot Horowitz, they wanted to kind of expand on this, and they said, wouldn't it be nice if we had something like it for database, right? And so they worked on it, and in 2009 they came out with something called MongoDB. It came from the word humongous, Mongo, right? And they make use of a NoSQL database. So there is no SQL. There's no structured query language to search or insert or delete from the database. It's all using a JSON-like structure. All right, so you make a JSON-like command on kind of in a command line. That's how it used to work, and then the database will respond by either adding a document, removing a document, creating a collection, and so on. Those kind of things that we talked about before. And so there's JavaScript everywhere. JavaScript on the back end, JavaScript on the front end, JavaScript in the middle on the database, right? So this is where this idea of a full stack, development came from. So again, gained a lot of traction. Mongo was really liked because it was so simple. One of the reasons why it was liked a lot is because it was very quick to kind of put together. It didn't need a complex schema or structure. So, and the tables collections could be non-homogeneous, which means every record could be totally different than every other record. You didn't have to follow a schema necessarily, although most people still do. So that means that like some records could have 8 fields and some records could have 20 fields. Each record being documents, right? That's what it was. And this flexibility kind of suited some of these developers. And a lot of companies started picking this up, big companies. Amazon, as a good example, MongoDB, and a bunch of other ones, right? I think Walmart uses the mean stack as well still, right, on the back end. So that's one thing that it became really, really popular to start doing this. So again, we're talking about back in 2009, right? They were starting to figure this stuff out. They were starting to look at frameworks. They're saying like, fine, we have a good backend now, and we really have an interesting database as an example, but one of the things that we have a problem is we need some kind of framework, some kind of front-end framework that can help us do everything, because we keep repeating the same patterns as developers over and over again, right? We access the database, we create, we inject code into the front end, and the single-page application in 2009 became popularized. It was like really super important, and everyone started doing single-page applications. Why? Super fast loading. I mean, think about this. I only have one page to load, and we're not talking about internet speeds that we have like we have today. Okay, 2009 was a different period of time, right? And we're talking now like 11 years ago, right? 11 years ago, the web has transformed over these last 11 years, right? And it's been made awesome compared to what it was before, right? In 2009, some people still only had dial-up. Dial-up was still a thing in 2009, right? Even in some areas today, there's still dial-up in those remote areas. They can't get high-speed internet. You have to use satellite internet in some places, even now, today, right? There still is this idea of a digital divide that divides us depending on the area that you're in. If you're in a rural area in northern Canada or someplace like that, you may not have access to high-speed internet like we have today, right here in population centers, right? So, so they were starting to think about, how do we make this better? And the single-page application actually is a way that we can use this dynamic kind of response to the user's requests. That's what we want. And we can use Ajax and jQuery. So jQuery was such a popular model, they were like, hey, can we not build up on jQuery and add additional functionality? Because instead of having these little component parts that jQuery gave us, can't we just make something that's like even better than jQuery that gives us like a whole front-end framework? And so AngularJS was made. AngularJS, right? And AngularJS was a project that was done by Google and Microsoft. Okay, so really, really huge. Okay. So again, it's like this idea of a rich web framework. It's also one of the things that Angular did at the time. This is back in the day, AngularJS at the time. AngularJS 1.0 was born, right? And they started developing some tools, but they started realizing that, you know what? We're heavily depending on jQuery. And jQuery has its limitations, like we talked about before. jQuery had been almost outmoded at that time. We're talking about like, 2010 framework, 2010 time frame, 2010, 2011, 2012. jQuery was slowly starting to become, less important because CSS3 had come out, HTML5 had emerged at the time, right? And you had this idea of, these giants coming together to kind of create this front-end framework. And Angular was almost like a framework for developers by developers, okay? It was something that they wanted to provide the community in order for them to have this support, a front-end framework that could kind of replace some of the older frameworks that Microsoft had and even that Google had, okay? Remember that Microsoft, when you use .NET, you have Razor on the front end, right? That's what you used to have. And you can replace .NET Core's front end right now with AngularJS or with React.js or something like that. So Angular was the big one. that came out. And Angular, they reinvented Angular, and they created Angular 2.0. Angular 2.0, when it came out, was 100% different than Angular 1.0 and had breaking changes. They were completely incompatible. When you had Angular 1 and you went to Angular 2, they were like, wait, Angular 1, all that work you did, guys? Yeah, just throw it out. And you got to think about that. Like, that's Google and Microsoft making something that they literally had to trash. I mean, they built on it, but then they had to iterate. And now I think we're now at a much higher version of Angular. I think it was, the last time I worked on this was Angular 8. So we've, kind of evolved from there. And it's a totally different framework. It's completely component driven. However, I have to tell you, on one hand, Angular 1 was simple and easy to use. It had a lot of flaws, right? Like setting up Angular 1 took a bit of time and everything else, but you could do it manually. Angular, the latest version of Angular, there's no way you can set it up manually. It would be a nightmare for you to set it up, right? Like by yourself, like literally by piecing it together, like how we did. There's no way. You'd have to download Angular, and you'd have to build Angular and deploy Angular as a package. You would have to, what Angular has, and we won't be able to get into Angular this semester at all, but what it has is almost like you create this fabric, this web application fabric that gets created, and what we do is we use Angular to create web applications. It's massive, and it's become more complex than it used to be. Why? We use a lot of design patterns, and Angular has moved into something where they use TypeScript for everything. On the back end, for the most part, it's all TypeScript, and we've kind of talked about TypeScript here together, really scratching the surface of what TypeScript can do for us. But TypeScript is a thing that a lot of front-end frameworks use. All right, so that created this idea called the mean stack: Mongo, Express, Angular, and Node. That was the mean stack. And if even today, mean stack developers are in high demand. Why? Because it's JavaScript everywhere, and it's a very technical web application framework to use mean. The true mean stack, not MERN, Mongo, Express, React, and Node. That's a totally different thing to do. Well, it's still, the back end is the same, but React and Angular, very, very different frameworks altogether. I would say Angular is harder to learn than React, okay? So that's the mean stack: Mongo, Express, Angular, and Node. So again, the advantage, single language, you still use MVC architecture. It has serialization, deserialization built in, so you don't have to have separate structures to do that. And everything is done using JSON objects, which is modern in the way things done. It's a REST framework, so that way it works in terms of it uses asynchronous connections to the network and a bunch of other really cool things. So questions around mean. So mean stack is what we're transforming into. We can't handle all of mean this semester because we're sitting at week 9, and mean, the whole mean stack takes me, we talked about yesterday how I keep teaching until the end. Yeah, I would have to do that every single day for 14 weeks for me to teach mean, and I did that. I normally do that stuff. In a 14-week semester, I can teach mean, and you would just scratch the surface of Angular. That's how much work is involved. Really, what you need is Mongo, Express, just like we're doing this semester, Mongo, Express, and Node. And one semester, just all you do is Mongo, Express, and Node. Manipulation, setup, all those things we talked about with a bit of JavaScript primer at the beginning. And then a whole semester of framework. Pick a framework, any framework. Angular, React, Vue. There's a bunch of other new ones now. And pick one framework and focus on that framework. That's how it should be done. And one thing should depend on the other thing. And if you had that, you'd have 2 semesters of creating the mean stack, and you'd be golden. You could pretty much work anywhere as a full stack developer. Okay, at least with some tools. You still lots of stuff to learn. I mean, you're going to build new things, but at least you'll have a good introduction into what you need to do. All right, let's talk about NPM. We talked about this before. We've talked about Yarn up until now, but really what NPM is the Node package manager for Node. That's what it does. Again, Node is this idea of a platform, right? And the way we update Node, and we've seen this before, is with NPM. Okay, so what NPM does is it has a registry of packages. Same thing with Yarn. If I go to Yarn or Node, NPM, I can download packages and install them directly into my web application without me having to go somewhere, download stuff. That was the old way of doing it. Download stuff and install it, and then make links by myself. I don't have to do any of those things anymore. The package.json file is the thing that links everything together and allows me to create dependencies and all that kind of stuff. Okay, that's what NPM is. NPM is the package manager for the web. What is it like in PHP? What is the package manager for PHP? There's a package manager for PHP. Do you guys know? No? There's a package manager for almost everything now, all right? There's a package manager for .NET. There's a package manager for Android. There's a package manager for iOS. And they have different names, but at the end of the day, all they do is the same things. They grab stuff, files, frameworks, libraries, and they inject them into the application. That's what they do. And they create a dependency graph. So what is Node.js? Again, going back to 2009, right? We had this idea of Ajax. That's why this is good that we've kind of transitioned from Ajax last week, that talk, to now we're moving into Node.js, because there's a natural progression. There's a natural progression, right? And this idea that one of the things that we're limited with Ajax, and I don't know if you noticed this right now, I haven't talked about writing files with Ajax, right? Like writing files with Ajax locally to a local file. It's just, there's security issues with that. Imagine that if I could go online and then write files to a web server, that would be bad, right? I mean, anything could be written, right? So typically that's not how it's done. You can't write with Ajax to a file. You can connect to files and read stuff. You can send things to a server to be processed with Ajax. For example, we haven't done that, but you can use PHP on the back end to connect with Ajax, and you can do a post request to process something like an email or a form or something, right? We haven't done those things. But you can't write to a file with Ajax. And they were thinking about how can we create these, this connection? How can we have this two-way communication between the browser and the server, right? So again, we talked about the V8 engine, and what they talked about here was creating something called non-blocking sockets. And non-blocking sockets, we basically created this idea of Node.js. Each socket was a node, as an example, and of course it was scalable. They talked about how to improve this. So 2014, we talked about this. This is the schism that I talked about between Joyent, the company that owned Node.js, and the original creator of Node.js. They kind of had, there was a kind of a schism, but what ended up happening was they came back together later on, okay? So I'm not gonna, that's just the history behind it. And I want to move on to event-driven programming with JavaScript. So again, everything in JavaScript is event-driven, as you've seen so far. You make an event listener, right? In the regular JavaScript we've been using today, right? I have an add event listener. I can put an add event listener on the window, document, an object, whatever I want, right? And once I create an event listener, what happens is it accesses something called an event queue that is asynchronous. It doesn't work in line with what you're looking at. Even intervals, if I make an interval with JavaScript, it works on a different queue in a different process. Same thread, but a different process than the regular process. So what ends up happening is you get response back at different times based on loading times, based on a bunch of factors, okay? So this idea of executing asynchronous code without causing blocking, no blocking, non-blocking code, is what Node.js is based on, okay? So here's an example of that. We talked about JavaScript adding an event listener, right? And we've been talking about using this idea of adding an event listener for half, I would say, of the course, all right? But the idea is the browser is single-threaded, right? And since the browser is single-threaded, wouldn't it be nice if we had a single-threaded event queue that you can access? And again, what they did before was they compared a multi-threaded environment like PHP. PHP actually uses a multi-threaded environment. And in the beginning, people thought, hey, that must be awesome. PHP, multi-threading, great, right? But the problem with PHP multi-threading is once I access a site through PHP, let's say you access a site through PHP, and then someone else accesses a site through PHP, it creates these threads and it holds them in memory and it doesn't get rid of them. It doesn't release these threads, right? So you have a bunch of these threads happening. And what happens is PHP starts to slow down over time. The longer the PHP server is running, at least back in the day, this is how it used to be, slower it would get. The more requests we make from a PHP server, the slower it gets. Why? It has to deal with multiple threads, and it has to deal with an overhead, a memory overhead, to manage all these threads, to access the same exact files, right? JavaScript doesn't, or NodeJS doesn't do that. So here's how NodeJS works. You have these event emitters, right? And these event emitters are things like listeners, right? Like before, we listen for a button click, we listen for a page to load, we listen for something to happen. It raises an event, and then it shuffles that message into the event queue, and there's something called an event loop that basically is listening for any kind of events to happen. And we have event handlers that basically handle anything that happens with the event listener. We have a listener and we have a handler. These two pairs of functions basically that happen, right? We can say we attach or bind an event listener to some kind of event, and then we bind a event handler to respond to the event. That's what we do, okay? So again, so a lot of resources, back in the day when we used PHP, here's an example of PHP database interaction, right? As an example, PHP is blocking, right? For the most time. There's a lot of stuff that happens when threads, once you create them, they just stay idle, like we talked about. They just keep waiting for someone to access the server, right? And it consumes system resources while they wait, right? Whereas, they try and solve this by creating this thread pool as an example, but the overhead involved and management of the server, again, has lots of disadvantages, and it still doesn't scale properly, especially when it comes to like these heavy duty times, like let's say it's Christmas. People are buying stuff a lot in Christmas, these times, Easter, other kinds of seasonal things that happen. And depending on which place you are in the world, you're going to have an increase of web traffic. Nowadays, it's the coronavirus that we keep on polling all the time. We keep on asking, more information about that subject. As more people access the web, especially a single website, more people access different threads on a PHP server, more memory is being consumed, and the web starts to slow down to the point where it stops working altogether. Okay? But not so in with Node. So here's a graph. You can see NGINX, right? NGINX is a very popular back-end server that works on Linux for Node.js. And you can see that as I get more concurrent connections, right? So here is Apache. So more concurrent connections. I start dropping in terms of performance. I can only handle so many requests per second, right? Whereas, if you notice, take a look at NGINX. It does degrade a little bit as you get to thousands of requests, but then it stabilizes and it teeters off a lot slower, right? We're talking about, thousands of requests every second, thousands of requests that it can handle, right? Your little server with a single threaded environment. So one thread, right? So this is where, Node.js became super popular. Why does Walmart use it? Thousands upon thousands, I don't know how many millions of users use Walmart and Amazon, those two services all the time. Netflix is another popular user of Node.js in the mean stack, all right? So you can understand, any kind of streaming services, Node.js, a lot of times they use Node.js in the back end. Okay? So again, you can see memory. Here's memory utilization, right? As the number of requests increase, memory utilization on an Apache machine will go up and up and up. Whereas on an NGINX machine, it'll stay stable. It'll never increase the memory demands for a machine on using Node.js. Yeah.
So why would you not use Node.js?
Why would you not use it?
Yeah, 'cause it seems like it's just better.
Of course it's better. But here's the problem with anything. Why do we use Java EE still? We had this conversation, right? We use Java EE, we use PHP, we use IIS, old school IIS, old .NET, and everything else because people have invested a lot of money, hundreds of millions of dollars in infrastructure, right? And they have these old systems, granddaddy systems that exist in their offices, right? They don't want to get rid of them. They still work.
But if you're going to make something new,
Who makes stuff that's new? That's the thing. Not a lot of people make new stuff. There's very few greenfield projects nowadays, right? The new greenfield projects, we transition, we move. Let's say, for example, my hardware is aging. I have a big company or a medium-sized company. My hardware is aging. And I host a web server somehow. I don't know why I would do this nowadays. Maybe for privacy, maybe for security. I host part of my web service in my location, all right? The other part right now, through a hybrid cloud, I have in the cloud somewhere, another part of it. The non-private part, the part that I want customer-facing. I use Microsoft Azure or Google Web Platform or Amazon Web Services or whatever I use nowadays, right? Some kind of hybrid cloud. But my backend might have some old technology, some PHP pages, internal sites for training, for things that we use in a larger enterprise, okay? We've spent so much money on mainframe systems that still exist today, right? And software technology that still exists today. How many WordPress sites are out there? WordPress is the number one content management system out there still, and it runs in the back end is PHP, right? So until those systems move off of PHP and move into Node.js, and until people have the need because of hardware requirements or whatever to transition, and it's happening slowly, most modern backends are starting to move towards Node.js. But we have a lot of legacy code out there. There's a lot of legacy hardware, and it needs to be supported. So even though PHP is dying in terms of popularity because of this problem right here, right? It still is out there. And it's still, I would say, at least 70% of our backend is PHP or something like that, or older technologies. 70%. Only 30% of our content right now, I would still say, is Node.js. It's improving slowly, and it's improved a lot. Before, it was like an 80-20 thing. Now it's 70-30. Eventually, it's going to be more, 60-40 and 50-50, and eventually it's going to be replaced. But it's going to take time. And they keep on coming with some new frameworks for PHP. One of the most popular frameworks for PHP to make it more modernized is Laravel, which is a great object-oriented framework, right? So there's other ways of modernizing PHP. One day, I think what they'll do is they'll try and make PHP as an alternate to Node.js, and they'll create something like this, some kind of non-blocking backend, a different architecture for PHP, more modern, more secure, and so on, and maybe more structured. Remember, with JavaScript, we can use TypeScript to create structure, and we can use Node.js. However, I really think that they're quite behind in terms of architecture. Okay, so as we move away from this graph, you can see that there's just so much more advantage to using this thing, and this is why, as a modern developer, modern web developer, you need to know about this technology. You've already learned about PHP, right? You've already done some PHP. So this is yet another thing to know. This is another part of your learning journey, if you will. But remember, with PHP, look at all the technologies we need to know to run on PHP. We had to know HTML, CSS, JavaScript, some kind of Apache to program the Apache server. If I was going to be a full stack developer, I need to know a little bit about Apache if I'm going to set it up. MySQL, right? And PHP, all those piece parts. Right? That's a lot of stuff to know for one person or two people. It's a lot. And to get good at any of that stuff, like you have to be a database administrator and everything else, here it's not like that at all. If you know JavaScript, HTML, and CSS, which mostly everybody does as a web developer, you can get going with a really cool modern framework. You don't have to know too much about database. You don't have to know too much about the back-end systems at all. You do need to know a little bit about Linux if you're going to do it all on your own, right? But at the end of the day, there's a lot of help out there to help you get going. And especially now with microservices and containerized systems like Docker, which I can't go into right now. That's a whole topic of another course altogether. Web services, right? or cloud services, if you will. Yeah, there's so much help for you out there to make you a good developer. One thing we have to talk about, there's actually a few things, but one thing we should talk about is something called JavaScript closures. And you're going to see a lot of this when it comes to NodeJS. Actually, we've already seen it. The IFI is a good example of a closure. The immediately invoked function expression that we talked about earlier on, almost the first thing we talked about in our course was the IFI. And I'm guaranteeing you, I bet you, here's a bet for you guys. If you talk to the other sections in this course, they don't know what an IFI is. Bet you, right? Why is that? It's not because it's not popular to use. It's because it's an advanced topic, right? It's self-executing code. I made you guys do self-executing code day one, right? That is different. Why? Because I know you need it. That's why. I know you need self-executing code, code that encloses variables and everything else that promotes information hiding and this whole object-oriented framework. So again, you can see a closure. Here's a closure. You have a function within a function. You have a parent function, and then inside there you have a child function, right? And you can call the child function from within the parent function, and the parent function from the global namespace. And that's what we've been doing, kind of. And it's kind of confusing somehow because it looks like function callback hell, right? That's what it can look like. A function within a function within a function. You've seen that with Ajax. It gets pretty squirrely, right? I call a function start. From my start function, I call something else. From that function, I call two things. I call 5 more functions, and so on. It keeps going like that. And that's how JavaScript is formed. And that's why when older versions of JavaScript were out, they looked at this code and they were like, wow, this is like spaghetti code. Okay? So closures. And there's more examples in here about what this looks like. Notice we can also do this, the idea of this child function equals the parent, right? I can do that. I can point one function at another. Even though the parent function itself is a named function called parent, I can create another variable, a constant in this case, that points to, with the equals operator, what I'm doing is actually pointing to that parent function. I'm getting a reference to the parent function, and I can call it separately like this on the bottom, right? Yeah.
Why would you do that over just calling the parent directly?
A lot of times what we want to do when it comes to this is we want to make aliases. Sometimes functions are very long or whatever. Or we want to use a function as a callback, just like we did before. Remember we did that thing with Ajax, where I used I passed a function as a parameter, right? So it's the same thing here. They're just showing that it can be done. All right, so parent and child functions, and I'm not going to continue more with this because you guys have got this. Let's talk about common JS modules. So back in the day, again, we had this idea of Common JS, which is a project that was started back at the same time that NodeJS was created, 2008, 2009. And one of the challenges we had with JavaScript, and you saw this already, right, is everything had to go through my index.html page. I couldn't link 2 JavaScript files together without going through index.html. But remember, Node.js, there is no index.html. How can you have JavaScript work on the back end without some kind of index.html? It doesn't exist, right? So what they had to have is some kind of module structure, some way of including stuff. Because remember, PHP has include, right? And what Node.js has is require. That's the key word we're going to use. We're going to use require to require a module, to inject that module, or that, and when we say module, we say that whole bunch of code. We're going to inject it in the place where it's required. Okay, that's how it works. Okay, so this idea of modules. There's a few parts to it. One is the require function. So whenever we call require, right, in Node.js, what we're meaning is include, import, using. Depending on which language you've accessed before, those mean all the same things. I require, right? And what's happening is it loads the module and injects a reference to that module inside of another, like some kind of a constant or a variable. Example, yesterday we did express is equal to, require express. So express is the module. We're injecting the Express framework and the library, and we're making a reference to it inside of a variable. That variable then becomes our Express representation of the Express module. That's what happens. Okay? Inside the module, we have to use the exports keyword. We're going to write our own modules, right? And the way it's going to work is every time we use the exports keyword, it's going to export anything that we attach to it. We can attach a variable, we can export a variable, we can export a function, we can export a class, and we can do multiple exports in one file. Anything we export is exposed outside of the file to other files. That means if I require a file, maybe that file has multiple functions inside, and each function can have its own export keyword attached to it. For example, export my function, right? When I inject it, when I import it, or when I require it, my variable that has a reference to the module, you can do something like this: my variable dot my function. Whereas my function actually has been written in another piece of code. That's how it goes. So you're going to see this functionality. So think about a module as a container that contains code that's outside of a single file. So basically what you're doing is you're connecting files together with this idea of modules. And here's an example of this. So let's suppose I have this function called hello.js, right? And I have this constant, my message is hello, right? And if I use an exports function, I have a little function called say hello, right? Say hello. And if I put exports, the exports keyword in front, exports dot say hello, what am I doing? I'm attaching hello, say hello, the function, a reference to the function, right? To exports. Remember, there's two ways of writing functions we talked about. One is named functions. Say hello. So we can write it like this: function, say hello, brackets, and then curly braces, right? Or we can write it like this: let say hello equal to an anonymous function, like this is how this is written, all right? So let's take that one step further. We can say that exports, which is an object. Exports is an object using CommonJS. I can attach a function to that object that's related to the file, right? And when I require that function, right, what's going to happen is I'm going to get all the stuff that's sitting inside the hello.js file. Notice that when I require something, if it was hello.js, like previously, here's hello.js, I don't require hello.js. I just say I want it, kind of require hello. You don't need to use the JS. You don't need to include that. It's a convention. Why? Because developers were like, well, everything is going to be JavaScript. Why would I have to include an extension? It's all going to be JS. So that's why you don't need to include it. Okay. So now, if you notice, if I have a constant, a receiving constant, this is the receiver. So this is the sender, exports, and this is the receiver, require, right? The require takes the data that I have here. So this little function says hello, takes that says hello function, and makes a reference to it inside the hello constant. That means that hello now is an object. It's not just a variable. It's an object that holds a says hello method that I could use. That's what it is. So in order for me to use the says hello function or a say hello function from this other module called hello.js, I need to call it with whatever the variable is, dot say hello. That's how it works. And we're going to see that when we start looking at Node.js all over the place. You're going to see this export idea. Exports, I want to export this thing, and I'm going to export it out of my file, and it's going to be required or injected into the other file. Why? Because this way I can separate my concerns. I can make smaller files that have a smaller amount of JavaScript, and I can put them in different places so they're easier to manage, right? And then what I can do is I can inject that functionality when I need to. And all Node.js modules, NPM, they use this idea of require, right? They have a series of modules, and one module requires some other module. And you can see that whenever we go back, if I was to look at node modules, let's take a look at node modules. Let's hop out of here and to go here for a second. So notice node modules are right here. And jQuery, I got Bootstrap, I've got Popper.js, I got a few things, right? This is node modules that I'm using for the front end, okay? But when if I did what I did yesterday with my application I built yesterday with you guys, which was using the Express generator, remember what we did with that one? My node modules looked very different, okay? It wasn't like this at all, actually. Okay, so let me just show you that one. So here is yesterday's stuff, right? Take a look at the node modules here. Node modules, man, there's a ton of them. Why? One module is required by another module, which requires other modules. Back in the day, when Node.js first came out, you had trees of modules that required other modules. For example, let's suppose I wanted to have cookie parser. Cookie parser would require cookie. So inside cookie parser, you would have its own package.json file, like it has now. Plus, on top of that, you'd have its own node modules folder, which has all the node modules. Sometimes you'd copy those node modules over and over and over again because they're all componentized and compartmentalized. You could have this node modules folder could be literally 500-600 megabytes because it's like you would have the same stuff copied 10 times. Now in modern Node.js, right, they've simplified. Once you include a node module, it links that node module to make it available to all the other node modules. So it shares the node modules together, which is a good thing. Sometimes it's not possible though, because some node modules require older versions of the other ones. Because every version, every module is a component, right? So again, if I notice here, if I go to the accepts module, you can see that it has a package.json file. And the package.json file, it has a request or dependencies. Here's all the dev dependencies. And here are the dependencies. I need MIME types and negotiator. Let's see if we can find that. So here is negotiator, and here is MIME types. Those are two modules that are required by the by this other module, by the cookie parser module, or the accepts module. That's how it goes. So one module depends upon another module, and so every module has its own package.json file, right? That's how it goes. And if I look at index.js for the accepts module, let's take a look at that. You can see that my index.js has some requires that it uses, as well as module exports. Module exports, this is a great example. I can look at all the code here. Module exports something called accepts. Accepts is a module. That's what it does. And accepts is a function in this case. A function. That's what it does, okay? And you can see that it has a bunch of other connections. Accepts, it actually creates this class, that's what it is. And accepts.prototype.type, that's like adding a property to a class. Remember, that's how we did it before back in the day. And you can see that, accepts in front of everything. And accepts sometimes uses functions or methods that they connect to and a bunch of other stuff. But at the end, guess what? We've exported this whole accepts module that I can import or require in another module. That's how things link together with Node.js. It's a totally different way of doing things than what we've done in the past. Although, for you guys, I'm sure it's fairly straightforward because we've used package.json the entire time. Okay? That's the idea. So going back to this then, so we've talked about require. So this is using CommonJS, right? And each module is self-contained. I can have stuff that I export, and I can have stuff that I don't export. Think about this as public-facing things that I want to share outside the module, and private to the module itself, self-contained within the module. I don't have to export everything. I can information hide, just like one of the principles of object-oriented programming. Okay? So here's how it works. Module.exports, whatever the function is, and I can export it. And I can require it over here. Okay, questions about CommonJS and the require. Again, I'm giving you all the background that you need, so when you see stuff, when you look at Node.js, you're like, okay, I get that now. I know what's happening. When I require something, I'm actually getting a module. Someone's written this module. Someone's written some JavaScript. and it's being injected right here. That's what's happening. Okay. So here's some core modules, and remember that Node.js core module, we talked about them yesterday. There's some that's built in. There's some modules you don't have to download. You don't have to use npm. Node package manager is only required for modules that are external from Node.js. And Node.js is a modularized backend. You can attach whatever modules or activate any modules you want that are part of the core. So if I don't need all of it, I don't need to require any of it. I can have the smallest server that I want, or I can have the most complex server with security that does things like e-commerce. Right? It's really up to you how much you want to attach or what you require. Okay, so we talked about this. So here's a core module. We talked about this yesterday. We want to require your file system module, and this is kind of exactly what we've done, right? We can look at the hosts file, right? We can read a file in, and then we have some data we can look at afterwards. The file system module is one of the most common ones, and it's built into Node.js. Okay, again, notice we're using require. The require keyword is using CommonJS, the CommonJS module framework, and then it's being stored inside of as an object inside of this fs identifier, right? So this is the identifier or variable, call it whatever you like. And here in this case, because the const keyword is being used, it's a constant identifier fs. It's an object that holds a reference to the the file system module that's part of Node.js that's built into the core. Okay. How about third-party modules? And we've seen those before. They get stored in something called node modules, a folder called node modules, which we've done before. And we have examples of this with Express as an example. Express is a third-party module. It's a piece of middleware. We're going to be talking more about Express next week. But really the way it works is this. Express, again, I make it a constant, require Express. So Express is a third-party module that gets, we create a reference to it, an object called Express, and this represents all of the classes that are with the Express framework. Okay, Express doesn't just have one framework; it has a lot of things that you can do. Okay, and then what we want to do is we want to make a new application, and so we call the Express constructor. That's what this thing is, and the Express constructor creates an instance of the Express object and stores it inside of the app identifier. That's what it does. So app then becomes an instance of, or an object of the Express framework. That's what it does. Okay? But first we had to require it. Requiring pulled it into this line right here. And once we have it, we can create objects of it. Okay? Pretty straightforward stuff. We could also do things inside of a folder. For example, if I want to attach a file, I can place modules inside of a folder, and then I can say whatever. Let's say, for example, I have a folder called modules, and I have that hello.js file. I can put that in there, and then I can require it, and I can store a reference to it here in hello. So I can do that totally, and we're going to see that a lot. Okay, I can put within a folder. There's another folder, and there's another folder, and I'm going to kind of contain my files or structure my folders so that way it makes sense logically for me. And that's what we've done with our Express generator. Okay? So when we develop Node.js applications, we're going to use a bunch of third-party modules. One of the most common ones was the Connect module, and Connect is what Express was built on. Now, I'm not going to talk about Connect because Connect is out of scope for us. In another course, I would spend a good class talking about Connect, like how to do Connect. And Connect looks very similar to Express, but I'd rather jump to using Express.js. But here's an example of server.js, which we can make. We've kind of did this yesterday. As an example, we can require HTTP. We've listened to a server as an example, and then we're getting a response back. We have two objects, the request object and the response object. Notice the fat arrow. Fat arrow is basically saying that these curly braces here, these outer curly braces, are part of the function, the callback function. That's what this is, right? So create server is a factory function that returns inside of HTTP, right? It returns an instance of the server object. That's what it does. Remember we talked about this. And we pass into its constructor a callback function. The callback function must include a request response object. The request object that's going to go out to the server and the response object that's going to be coming back. That's how it works. Okay, and we've done this yesterday where we kind of started our servers. Let's do one more thing. So that's kind of a Node.js, a very high-level view of Node.js in a nutshell. And that's on your content. That's for you to kind of use here. I've kind of put the PowerPoint right here at the top that you can look at later. I think it's good reference to understand what Node.js is. On an interview, when they ask you if anyone asks you what Node.js is, you would say that it's non-blocking. It's using JavaScript on the back end. It's based on the JavaScript V8 engine, right? And it uses a single thread in order for us to serve up files to our users. That's what it does. Okay, as a kind of an overview, and it replaces back-end servers like Apache or IIS. That's what it does. Okay. So going back to what we did last day, which is again I built this system by using the Express generator. Here's the Express generator, and I'm just going to shut some of this stuff down. So hide it. I have a public folder, and I have this views folder. All right, here's my views folder. Let's explore this framework a little bit more. We're going to do more of this next week, right? We're going to do more of this next week, but I want to explore the framework a little bit more. So notice again, on the front page here, there is no index.html anymore. Why? Because this, my friends, is the server. The server stops pretty much right here. Roots. Public, you can have regular JavaScript inside there if you want. Any regular JavaScript or CSS can be housed right in here. Styles.css is a common CSS file that is being used right now. And so let's take a look and see how that's done. So again, remember that server.js, if we're going to trace it, this is the entry point, server.js, right? So it starts here. And what server.js does is it requires app.js, right? So notice up here, and by the way, we have some of these vars. Let's get rid of them. So again, I'm going to fix that up. So I'm going to kind of find and replace all vars and replace them with either consts or lets. Highly recommend that. Just because they're there doesn't mean you should leave them like that. You can modify this code as you see fit, right? So you can see these are all lets now. And what happens is, if you notice, on line 7, what I'm doing is I'm saying, hey, let's inject a reference to my app right here. Okay, right here. So app.js is what it looks like. Remember, we don't have to put the .js. We don't have to put .js with require. And I'm going to go back to my app.js file here, right here, to take a look at it. Let's see what this looks like. Here's app.js. App.js includes a bunch of other modules. It includes 1, 2, 3, 4, 5, 6, 7 modules, right? Right? 7 modules. Here are all the 7 modules that it includes. So the first thing it does is it starts to include modules. It says, okay, I want to create error. I want to get Express, obviously, because we're basing everything on Express. I want the path module, which is a built-in module to Node.js. We talked about that yesterday. Cookie parser, which allows us to parse cookies. Logger, an index router, and a users router. Let's talk about these two things. So these are not modules. These are files, right? So we're going to basically look at these ones, and I want you to think about these as controllers. Okay, we talked about the model view controller framework, right? Again, model is a class that connects to a database. We don't have that right now, right? We have views, which we're going to see, and controllers. These index router and users router are 2 controllers. So what happens is as we inject modules, then we start requiring our controllers. This is our logic for how our app works. So let's take a look at here. Let's take a look at our routes index. So again, if I go to routes folder, and if I look at my index.js, you can see here that even here I inject, let's just change these to lets. So again, I'm going to find any vars, and I'm going to replace them with lets. There we go. By the way, back in the day, when Node.js first came out, didn't support let or const, because that's ECMAScript 2015, right? Remember? ECMAScript 2015, that was way after Node.js, which came out in 2008, 2009 timeframe, right? So it didn't support the latest version of JavaScript, okay? So let's just go back here. So again, in my index.js, which is in my routes, the way you would look at this is the index route. The index route, okay? Think about what that is. Index route is like the main route for your main page. If I was going to go to your landing page, your home page, the index route will take me there. And that's exactly what happens here. Take a look. It goes like this. I want to require express. I want to require the router. A router is actually an express function, an express class, if you will. And I'm going to use this class. Router, I'm actually instantiating an object of type router here. That's what I'm doing. And router, I'm going to go router.get. Remember, I'm going to make a get request. And anytime we see a slash like this, it means get the home page, get the main index. If I don't put anything in my localhost, if I go localhost 3000 and I press enter, I'm not putting in a page like index.html or something. That is the root of my application, and the slash, this / means root of my application. I want to go to the root of my application. That's what it means, okay? So when I get to the root of my application, I'm going to use the get request, and the get request can use this function. Notice this function is written old school. I can rewrite this function with modern JS, so to make it look like this, right? Using a fat arrow function, where I get request, a response, and the next function. That's what it does, all right? But notice I'm not really using next right now. All right. So this, what it does is it says res, the response, dot render. I render a page called index. That's what I render. And inside the index page, I'm just going to put it out there, so I'm going to put it across different lines. I pass in the index page, I pass in an object that I can read in the index page with a property of title. Okay. Don't lose me here, because this is where people get lost when I do this, okay? So first, this part right here, right? This part right here is the route. The stuff that's inside here is the logic. I do things, when I get this route, this is the router, I can separate my logic away from the router. My router is just that. It just says, hey, when I go to this particular site, do this. I don't have to do that here. I don't have to pair my router and my logic, my controller. I don't have to put my controller inside here like I have. I can take my controller and put it inside another folder, a controllers folder, and we're going to do that later on. Right now, we're putting it together because it's easier for us to look at, okay? All right, so again, so we do this first router. The first route is the root. This is the root of our page. And it tells me when I go here, access the index view. That's what this does. When I go res.render, render looks at the view. Look and see how it says render, and then it says view, which is a string. It's right here. Look, it's right here. A view that's a string, okay? So it says, which view do you want when you go here, when the user goes here? Well, I want inside views, remember, because views is part of the path. If you forgot about that from yesterday, if you look at the app.js, what we did was on line 14, we set views as part of the path. So I never have to put in the folder views on my URL. I don't have to go views/index. I don't have to do that. I just have to put index. And views, it'll search, your web server will search inside of views to find your index content. That's what it's going to do for you. Okay? Same thing with public. Notice public is there as well. Not only is it part of the path, but it's also static. So I don't have to mention anything to do with public whatsoever. and I have access to assets, content, and scripts. Anything in assets, content, and scripts, I just have to say /assets, /content, /scripts. It makes it easier for me, right? Whereas, if I didn't have this line here, right, on line 21, right, then I would have to put in localhost /public/ whatever. This way I don't have to do that. Okay, so that's what join means. The path module, which is part of NodeJS, allows me to join stuff onto the path, onto the URL. So I don't have to request it. It's just part of it all the time. It's implied. Okay? So if that's true, when I go back to my route then, if I say index, what I mean is look inside the views folder and look for index.ejs. Notice it says EJS. Why? Because when I installed my Express generator, I chose what type of view engine that I wanted to use. There's many different view engines. The most popular one that they try and push on you is Pug. Not really a fan. It used to be called Jade, actually. And I like EJS because it's much more straightforward for students to learn. Pug, it's a shorthand. It gives you a shorthand language for how to write HTML. EJS is HTML. It looks like HTML, right? So if I look inside my index.ejs, you can see that it looks like HTML, right? Isn't that true? HTML. This is not HTML. This is HTML that's inside of another file. It's an EJS file, guys, EJS. And I want to point some stuff out. You have inside EJS these little left angle percent equals and percent greater than sign. These things here, these might look familiar to you, right? If you've done PHP programming. If I do left or less than percent equals, what I'm doing is I'm injecting an object right in here. So this is a really cool thing about Express. What I can do is I can take objects and I can inject it dynamically into my page, right, from the back end. Okay, let's think about that for a second. That means I can construct my page. This page is not an index.html page. This page is going to be constructed into an index.html page, an HTML page at the end. I'm going to render this page as an HTML page, but it is not an HTML page. I just want you to keep that in mind. Why? Because it looks like an HTML page doesn't mean that it is. Remember, this is JavaScript. This is a template. I'm going to use this template just like we've done remember those template strings we used? Think about this without the strings at the end. That's what this is. It's a template string. And I'm going to inject this whole template string inside the document. That's what I'm doing. Okay? It makes it so it can be very powerful. Very, very powerful. Okay, so that's what it does. Let's take a look also at, let's go back to our router. So our router only does is it looks at one route, and it has two parts to it, the render part and this part right here. This is an object. This object here has a title property. The title property has a value of express. So going back into my views index.ejs, I inject the title property in here, which has the value of express. And so when I go to the page, right, I want to go to my page. Let's do that properly. So I'm going to go to localhost, right? This is what I get, right? I get express. But what I'm really getting here when I get express is this is not real. This is not real, right? Let's take a look. Let me do my view page source here for a second. What's happening is this page here is being constructed from my node server in real time. So when I request it, it's taking my template, injecting anything I want into it, and then rendering it for me. Okay? Make sense? Questions?
Was it render server side or client side?
Client side.
Okay.
First, it creates it on the server side, and then it renders it client side. Okay? All right, so if that's the case, how the heck do I use Bootstrap? Because I want to use Bootstrap again, right? I don't want to do this. I don't want to have my own CSS. I'm not a CSS guy, right? I'm a web application developer. So are you, right? At this point, you guys are, you know, you can use CSS or whatever if you need to. for the most part, most people don't know how to use CSS like we talked about, but they use really cool CSS frameworks to make it look nice, like Bootstrap. How do I do it? And how do I use Bootstrap like we used it before, where I used NPM and Yarn and all that stuff? How do I do that? The same way we've been using it all this time. But we're going to have some issues. And we're going to talk about this in a second. So remember, node modules is something we want to get to. And yet, when we look at node modules is not on the path. So if I want to use Bootstrap, I might have some problems doing that, right? Especially if I do something like this. If I go control backtick, right? And if I say something like, I want to have access to, first of all, let's write nodemon. Here's nodemon. And notice how it crashed right now. It crashed. How come it crashed? Because right now, my port 3000 is in use. Somewhere or another, I've run port 3000 in the background, and I can't run port 3000 again. Let's just kill VS Code. Hopefully that'll kill the ports and bring them up again. And the way to test that, actually, let me just do that again. The way to test that is if I go back to here and if I refresh, it should error out. But see how it doesn't? See how this is still running? This is a challenge when it comes to NodeJS and Express, right? Because I have my node server running in the background somewhere, it'll keep running until I kill it. Okay? One thing I can do is I can press Control Shift Escape. And Control Shift Escape can give me all the stuff that's running in the back end, right? So I can look at, this is my little task manager, and I can look at all my processes, and if I want to, I can kill any of the tasks that I see that are up here. So here's Node.js. You can see that is running. See that? I've got a Node.js task that's running right here. And we can explore what these things are, right? To look at them. Here these are the things that are being used right now. And I can attempt to shut some of this stuff down. Caution, guys, when you do this kind of stuff. Again, if I want to end my task, I want to end my server-side JavaScript, right? I want to end my task. I want to try and do that. It may not do what you want it to do. So that's just pointing it out to you, right? It may not do what I want. Notice how it launches it again, right? So just make sure that you know what you're doing here, because right now what's happening is we've been trapped with the Node.js in the back end that's working. All right, I can always point to a different, and then here's all the other processes. I've got these console window hosts that I'm running, right? I got a client server runtime process. Again, we can try and, kind of identify which of these services are running, right? But I may not be successful. I'm just putting it out there. Okay. We can also try stopping Google Chrome, but then I would stop my broadcast. So I don't want to do that right now. So again, notice that Express, that's still running, right? But we can shut it down. And the way to do that is I can run this. If I bring this up, I can run it on a different port. I can always change ports to play with, right? Let's put it on port 8080. That was a good example. How would I do this if I was going to put it on 8080? I go to my server.js, and the port that I'm listening to right now is port 3000. I can literally just change this to port 8080, and I'm good to go. Now if I run this thing, so control and backtick, to bring up my node modules, or sorry, my nodemon, I can run it on port 8080, right? It'll run on port 8080. So if I go back and try and run this thing, so here this will run, but I can also run my thing on 8080, right? You can see that that's running now. I'm just doing this so that I can keep going instead of trying to find out where my process is that didn't shut down properly. Okay, you might have this problem too. All right, cool. So you can see that I've got my favicon errored out again because I didn't have that. I want to start including some of the things we've already done, but I want to do it in a kind of a semi-intelligent way. And so the first thing I want to do is load up Bootstrap, jQuery, and all that stuff again. How do I do that? So again, I can say that, and I have to point this out as well, right? Remember that I have node modules here, right? I have node modules here for a second. I don't know what that is that I got there. Something that was inside my buffer. But these node modules are server side, right? Everything that's inside here is all server side node modules. But remember, right? That I have this public area here. And this public area, my friends, has access to things like assets and scripts. So this scripts, notice there's no scripts file. Let's make it a script. We'll make an app.js in there. So we'll make a new file called app.js. Here's my app.js script that's inside here. To attach this file like normal, let's make our iffy like normal. So we'll call this the iffy, right? And we'll do the same thing that we normally do with our iffy, right? This is our iffy that we normally write. Here we go. And yeah. And inside there, we'll make a function called start, just like we've normally done before. So this is all the same stuff, right? So function start, right? And we'll do a console log. We'll say app started, right? It's kind of what we did before. And what we also did with this is we also attached a window. So window dot add event listener on the load event. We talked about this, access start. That's what we said, right? That's what we wrote before. All the same stuff we've done, okay? But this app.js is inside of our scripts folder that's inside of our public folder, yeah? So what I want to do is I want to attach this app.js in my index. So if I go to my index.ejs, in here, here's my index.ejs. And I want to attach it at the bottom, right, of my body, like my body tag as normal. I would try and write it with emmet, right? Remember, in Visual Studio Code, I have emmet, and I start writing script, and then I got nothing. Why? Because VS Code is identifying this page as not an HTML page. It's identifying it as a EJS page. This is not an HTML page. This is a template, actually. So I can change this down here where it says EJS. I can switch this over to HTML. So I can go to HTML. Right? And once I make this into an HTML page, some things look weird. It says, hey, I don't understand what these are now. Because HTML doesn't understand percents, less than percent equals. But don't worry about that. We need it for the EJS, the emmet stuff, right? So I can put in some code like this. I can say that, so scripts go there. And I can attach, like I normally do, a script. It kind of starts working again, script source. And I can go /scripts. Notice I'm not getting hinting for this. And /app.js. Okay? So there it is. I've attached it. Notice I didn't have to use the keyword or the folder public. Because scripts, because it's inside the public folder, it's available statically. I can access it from anywhere, right? And if to show you this, here's my server. Right? If I refresh, and if I go down into my inspector now, and I go to console, you can see that it says app started. Right? Because I've attached this script to the index.ejs template, right? I can access this script like normal. Okay, cool. This is great. But how do I attach node modules that are client-side now? I need to do this. Well, it's using a separate package.json file. A separate package.json file that sits inside of your public folder and a separate node modules folder that sits inside your public folder like normal. So let's ignore everything else for a second, ignore all this stuff, and inside my public folder, inside this, right? So again, I need to navigate there, so control backtick. Notice that I'm inside lesson 9. I can't go be in lesson 9 anymore. I got to be inside my public folder, right? And then I can do the same thing that I've always ever done. I can say yarn init. Yarn init. I'll be okay. And I can see, instead of public, we can keep it as public if you want, doesn't matter. Just press enter, enter, enter for now, okay? So it creates a package.json file inside of my public folder, yeah? And then, just like normal, I can just do yarn add jQuery, right? Yarn add bootstrap, right? yarn add, it's at, is it at Fort Awesome dash font awesome? I can't remember. At Fort. Let's find this is where the part that I forget. I'm so sorry. Yarn add. Yeah, it is this one. So sorry about that, but I want to make sure that I got that right for you guys. So I want to do this, right? I want to get that stuff. Unexpected error has occurred. It says registry yarn at Fort Awesome. Is it a dash? Sorry, I want to make sure that I get the right thing going on, right? It's just a matter of copying it in properly. Yarn add. There we go. I just didn't type it in properly. All right, so that does that, and you can see that I have some dependencies, right? And then, if you notice now, inside of my public folder, right, there's another node modules folder, right? So these node modules are for the server, and these node modules are for the client. And in fact, we should name them that way. We should say that this is called client, not public, if you really want to. We're not going to get there yet, though, not today, because we're kind of timing out at this point. But now that I've got this in here, and it's available to me like normal, right? Because I got node modules in here. I've got like Bootstrap and jQuery and Fort Awesome, right? Then I can do the same thing I normally did, which I can go to my views, EJS, and I can include all that stuff in there, right? So I can do things like, instead of this link, by the way, I don't want to use this link. I want to make my own app.css. Let's rename this thing to app.css. Rename. App.css. Let's make that app.css. And this is going to come off after the other links. So I'm going to say link CSS. And I'm going to say that I want to look at, now this is where it's more challenging for us because we need to have, there's no code hinting when we do this, right? So I'm going to go into Bootstrap, so node modules. So again, it's dot. And it's like slash because one thing to notice I'm going slash content. This may have to change to dot slash. Let's try dot slash here. Dot slash node modules slash, and I'm going to go into Bootstrap. So Bootstrap. And then slash into dist into CSS. Right? And into bootstrap.min.css. Bootstrap.min.css. Okay? So that is our CSS. We'll do the same thing for Font Awesome. So again, I'll do a link. Right? CSS. And then I'll do the same thing. I'll say that this starts off in node modules. So dot slash node modules slash at Fort Awesome slash CSS all that min.css CSS all .min.css, and that covers us from a CSS perspective. And then we're going to do the same thing for our JavaScript. Just like normal, we'll put in our third-party libraries in here. So we'll say third-party JavaScript libraries. Right? And that's where they're going to go. We're going to say script source, and we're going to go dot slash node modules slash, and again we want the jQuery stuff now. jQuery's got to come first when it comes to using Bootstrap. So jQuery dist, and then it's jQuery.min.js. So jQuery dist and then jQuery.min.js. Okay, that's that one. That's jQuery. And then script source /node modules / again, we have to go back to Bootstrap because we have to have the Bootstrap stuff set up. Dist. So Bootstrap /list dist /js /bootstrap.min.js if I'm not wrong. Bootstrap.min.js. There we go. We typed it in manually, but it's there. Okay, so those are what we need to do. All right, and if we've done everything right, then we'll see everything that happens in the right way. Let's put /content just to be for completeness, right? And now when we go back to our code, which is here, and if I refresh, you can see that now, my friends, we have a okay, and it says we have one problem, which is at Fort Awesome CSS all.min. It says .net error aborted 404 not found. So we didn't get the right address here for Fort Awesome, but we got everything else. Express and Bootstrap is working properly. You can see the font has changed. Let's see what the problem was with this one. So at Fort Awesome /CSS and node modules. Let's see what that is. So again, it might be just the pathing that's incorrect. Oh, it's Fort Awesome /font awesome. Fort Awesome /font awesome. Font awesome dash free, actually. So Fort Awesome font awesome dash free. That's the root. And this why? Because this is buried inside the other one. All right, so if I did this, then if I refresh, we should be good. All right, so that is an example of how we get code, just like we normally do. So if we know this, then we can do everything that we did before. All the stuff, the beautiful things we did before with JavaScript and HTML and Ajax and everything else we want, we can do here with inside of our public folder. We can treat this public folder like it's the client, because that's what it is. Our public folder is the client in this case. So how about if I want to have I want to separate some of this stuff. I want to have all the same things we had instead of having all this, right? Well, let's take a look at that example. So we have some examples from previous code. We don't have to reinvent the wheel here because we have it, right? If I go to desktop and if I go to WEBD6201 and if I look at last week's lesson, let's say, let's take a look at last week's lesson, which is in our views folder, we have actually, let's do last week's folder. In our views folder, we have this partials folder, right? And in our partials folder, I have my header.html. Here's my header.html, right? That looks like this. Let's open this up. Let's open it up with VS Code for a second. And you can see that I have this navbar right here. What stops me from taking this whole navbar right the way it is and injecting it inside of my code? I can just take this navbar, and if I go into my index.ejs, right? I mean, I could inject it right here. This is wrong because we're going to use partials in here as well. But I could just do this, right? I could just inject that main nav inside my index.ejs. And if things go well, we should see similar functionality to what we've seen before inside of my page. If I refresh now, you can see that there's my navbar. Hey, here's something that's weird. I got my navbar, but it's like kind of in here. It's sitting here, not everywhere else. Why? It's the way I've injected it. Remember, my navbar actually injects instead of a header that's a container, and I didn't do that. All right? But look, it did work. I mean, I have the same functionality that I had before, and it's inside of using Express. So next week when we get back together, just to recap for next week, we're going to rebuild our web application that we've been building this entire semester by using Express and the Express generator, the scaffold that we made with Express generator. We're going to rebuild everything so we can use everything as normal next week. Okay, all the pages are going to be accessible just the exact same way we've been using them so far. All right, but instead of using Ajax and injecting our page, we're going to use the view engine that's built into Express, which is called EJS, to inject or render our pages for us. Okay. Okay, as a reminder before you guys take off, remember that Lab 3 is due Monday, next Monday, so please get started on it. It shouldn't take you long. It's a short lab that should be fairly easy to do. And look for test 3 on Tuesday. As soon as we get Monday done, I'll use that template to create test 3 for you guys. It'll be due next week. Okay, guys, thank you so much. I'll see you next week.